Okay, so let's go through this simple thing. This is the Mazzilli oscillator. It's really pretty simple. A couple resistors, protection diodes, MOSFETs. This is one drain, this is the other drain, common source to ground. It goes to this capacitor, and this capacitor goes to this red winding in here. The scope is across basically the ends of this coil, which is the sides of this capacitor, or the two collectors here. Those are all in parallel. This is times 10 on both probes, all 4 probes. So this is 20 volts. This is 20 volts. This is 1 part divisions. This is the Mazzilli. This is this output coil, which goes to that load, to this load on one side to ground, and to this bridge rectifier here, to this capacitor that this meter's across. So I'm collecting 28 volts very slowly, and I can discharge this with this. It goes down to 0 volts. And then my signal goes like that, and as that builds. Okay. So this pulse in the middle here looks like that Stanley Myers pulse. So this is held low, and I let it go. Then we get 30 volts in the output, which 30 volts isn't quite enough because it's really only 15. This is 60 volts, 40 volts I guess, because this goes up to 81, and that load comes on, and this is 17 volts and 0.36 amps, but so if we have very low voltage, this is the frequency of 5 megahertz. And then just slightly more voltage and it pops into this, which is like 240 kilohertz. As I increase voltage, my size is not increasing. Once this load turns on, I can do it without tripping whatever's going on in the power supply. I don't know, it switches a relay internally at that point too. So there's a short pulse in the beginning which disturbs everything and turns those on or something. There should be almost enough voltage for them. But then they fail and then they start conducting. And then these go out for a while and then give it a little more voltage. And twice. Right now that's the same current as that, the 0.33. Okay, that's more. But then, my signal stabilizes out instead of being so noisy. And these kind of flickering. And a little more voltage and it stabilizes again. And this is still 281 kilohertz. You know, it's only a 36 microhenry coil. 3 of them. Okay, I was wrong. This outer coil is currently 74 microhenries. The red one is 72, 74. No, that's me touching it. Microhenries is pretty low though. I would measure the other one, but it's going to be lower. Oh right, and this coil is now just shorted on the one end. I had these grounded initially, so I had 2 independent paths from ground to voltage. But I combined them and now I have a differential voltage here, which it's combined at the end. So basically this is a caduceus coil. Or this would be all the way up 1 and back down on itself. So the 2 ends I don't know. I mean, there's a positive differential here, definitely. So this inside coil, I actually do have probes on, and let me isolate it from the circuit. Just right. So 62 microhenries. 62 microhenries. 71 and 71, shorted at the end. Makes it either caduceus or bifiller. Differential output is it's disconnected. So back to being on. This is the signal on these ends of this coil. I guess every cylinder coil does that. I don't know.